Hello, welcome back to Work 70 Math. I'm going to go over the 2005 Aime Ii number 10. Given O is a regular octahedron and C is a cube whose vertices are the centers of its faces, we have to find the ratio of the volume of O to that of C. Right. So here you can see I drew a pretty good picture of an octahedron, which has 8 faces, which are equilateral triangles on the outside, and then in green I drew the cube whose vertices are the centers of the faces of O. Okay. It's actually a really simple geometry problem. So we have to find the ratio of O to C. O is the octahedron, C is the cube. So the ratio of the volume of O to the octahedron to the cube. Okay. So oops, this better become green. Okay. Now I'm gonna draw black. So the faces, the centers, this is the important part. So if you take the center of this, it's gonna be where the medians intersect, it's gonna be the centroid. That's what it means by center. Which means it's going to be 1/3 of the way to here, 1/3 of the height of the equilateral triangle, 1/3 of the way up. So like for this face on the side, for this face on the top on the right side, the center is going to be 1/3 of the way to the top. By similarity, it's going to be 1/3 of the height up as well. So let me draw to help you get a good perspective on it. I'm gonna make this. I'm gonna make this the middle of the octahedron its own plane. So you know where the diagonals are? That's the middle plane of the octahedron. There's 4 faces on top, 4 on the bottom. Okay. So from the center of this, we now know the height of the cube already, because the cube's vertex over here, the cube's top face, in fact, is going to be 1/3 of the way up. Because it's 1/3 of the way diagonally, it's going to be 1/3 of the way up. So first we have to define some lengths. Okay, so we can define it to be anything because we only need the ratio. If we let the side length of the octahedron be 1, okay, so then the height, we have to find out the height. So this would be, so this length of the cube, half the height of the cube is 1/3 the height, which means I'm gonna let the volume of the cube just be C. It's gonna be, the side is gonna be 2/3 times the height, and the volume is gonna be that cube. Now we can find the octahedron's volume. Alright, so first of all, we can find the height of the equilateral triangle. We have 1, 1, 1, which means this is going to be √3/2 because it's an equilateral triangle. We can use the Pythagorean theorem or something. Okay. It's lagging for some reason. Okay. Anyway, we have, now if you take the horizontal, no, if you take a vertical cross section like this, if we take the midline of the left and the right faces on the top, and then connect this midline of the center plane, we get this triangle. It's an isosceles triangle with side lengths √3/2, and then this is equal to 1 because the middle is going to be a square. In the octahedron, the middle plane is just a square. Right. So now split this up. We get 1/2 √3/2. So we get 3/4 minus 1/4. Okay, we get √2/2 as the middle height, and that height is going to be the height of the octahedron. So h equals, I'm going to let it be 1/2 because it's going to be easier to simplify things then. Right. Now we have to find the volume of the octahedron, and you may have noticed we can just simply split it up. We can just split it up into 2 pyramids. Okay, so on each of them, we're gonna have 2 pyramids, right? So it's gonna be 2/3. I'm just multiplying 2 by 1/3 because the volume of the pyramids will be 1/3 times. Each of the pyramids are gonna be 1/3 times the base times the height, and we have the height over here. I'm gonna multiply the height first. Something is wrong with this. Alright. So now the base area, it's just a square with side length 1, so it's 1. Alright, we don't need that. And now we have to find the ratio from O to C. So we have 2/3 h to 2/3 h cubed, which is literally just 1 over 2/3 h squared of this squared. And actually, the cube has the octahedron. Something's wrong here. The volume of O to that of C. Wait a second. So it's gonna be 1/3 of the height, and then 2/3 of the height is the side length. Yeah, correct. Alright, so yeah, the octahedron obviously has more volume, which means that cube must have a volume less than 1. Okay, it works out. I was just checking whether it's true or not. So the cube will have a lesser volume as long as 2/3 h is less than 1. Okay. And this is going to be 1 over 4/9 times h squared, which is, if h is 1 over, so it's 1 over 2, it's going to give us 1/2. That becomes 2/9. Alright. And the reciprocal of that is going to be 9/2, which is simply 11. 11 is our final answer. Alright, thanks for watching, and I hope this helped you.